I have a secret for you. Most students who fail calculus actually understands the calculus part. They get the derivatives, they get the integrals, but they fail because of this. Their algebra is weak. So today, I'm going to show you the 4 most common algebra mistakes that could kill your grade. So make sure that you don't make these mistakes on your exam. Okay, so let's begin with the first one. Okay, let's write it here. So mistake number 1. The first mistake, I titled this one as linearity errors. Or this is also sometimes known as the freshman's dream. Okay. Oops. So let's just resize this a little. There. So what do I mean by this? Let's have an example. So say we have here x plus y squared. What most students would do is that they would just distribute this square individually on these terms. So they will obtain x squared plus y squared. But this one is incorrect. This is not true. As a quick example, suppose we have x and y to be 1. If we follow this idea, then we will obtain 1 squared plus 1 squared, which will yield us 2. But take note that when you simplify this one, you'll get 2 squared, which is just equal to 4. Clearly, these two are not equal. So the correct way to do this is to apply the square of a binomial method. What I mean by that is, if we have this thing, what you do is you apply the formula, or technically you apply the FOIL method twice to obtain x squared plus 2xy plus y squared. There. So that is the first common error. Other forms of this includes the following. So let's say if we have a square root here of x squared plus y squared, suppose we have this. Another common error that students do is that they distribute the square root on both the terms. So we'll have here square root of x squared plus square root of y squared, which yields x plus y. This one is also incorrect. The correct way to do this is to just stick with the correct way to do this is to just stick with what is given to you. Since when you have this form, you can't really simplify it anymore. Okay. Another example. Another example of this is, say we have 1 over x plus y. Common error here is to split based on the denominator. So we will obtain here 1 over x plus 1 over y. Oops. This is also obviously wrong. A quick example there is to use x and y to be 1 as well, like earlier. Okay, so the correct way to do this is, again, to just stick with it. To stick with what was given to you. So we'll have here 1 over x plus y. Or if you want, you can write this one as x plus y raised to negative. So this one is correct. Yeah. Another example. I have plenty of examples for this one, since this one is one of the really the most common mistake that I personally So we have here ln of x plus y. Common error here is to split this to be ln of x plus ln of y. This one is incorrect. Okay. The correct one is for this splitting to apply, what you must have is a product. So let's say ln of xy. So this thing here is a product. When you have a product inside the ln, what you get is ln of x plus ln of y. This one is correct. Yep. And then last one for this. Last one for this is if we have sine of x plus y, common error here again is to split this to be sine x plus sine y. Similar to earlier, this one is again incorrect. The correct way to do this is to apply the formula. So we'll have your sine of x plus y by trigonometric trigonometric formula for or identity. For sum inside the sine, you'll get sine x cos y plus let's see, yeah, plus cos x sine y. I hope I got this correctly. Sine cos sin cos. Yeah, I think this one is correct. So yeah, so these are the most common errors for this first one. So make sure to avoid this one. Just fix this one. There. Let's move on to the second mistake. For the second mistake, I call this one the cancellation crimes. This is absolutely a crime for me. You'll also see a crime on your paper if you do this, since that would be plenty of red marks. So kidding aside, let's have an example. Say we have x squared plus 2x over x. A common mistake here of the student is to cancel this and this, since in the numerator and in the denominator we see an x. This will yield an answer of x squared plus 2. But again, this one is wrong. The correct way to deal with this is oops, wait a second there. The correct way to deal with this is to first factor out the numerator. So for the numerator, you'll have here x times x plus 2. And then you cancel out the x's here. It's not evident. Let's use yellow. That would yield x plus 2. Clearly, these two things are not the same. So that's a common error, canceling out the variable. Another similar to this one is the following. Let's say we have 3x plus 5 and then 3. You may guess that a common error here is to cancel out this time the common constant, which is 3. This will yield an answer of x plus 5. But take note that this one is incorrect. The correct way to do this is the following. So let's write it down. 3x plus 5 over 3. To do this, take note that when you have a rational expression of, say, a plus b over c, you can write this one as a over c plus b over c. So you can split based on the numerator but not on the denominator like earlier. This will yield us 3x over 3 plus 5 over 3. But this time we can cancel out the 3's out here, leaving us with x plus 5 over 3. Again, clearly these two are not the same. Whew. Yeah, so okay, let me adjust the spacing later. Let's leave it like that. Last example for this mistake. Let's see, we have x squared minus 1 all over x minus 1. A common error here is to do a combination of mistake number 1, which is linearity error, and mistake number 2. So what the student do here is that they split based on the denominator and the numerator simultaneously. So they will obtain x squared all over x plus -1 over -1. So this one was combined, this 2 must combine as well. We cancel here the x's, then this one, leaving us with x plus 1. Okay, let me adjust this one to move over probably here. There. But take note that this one is incorrect. Okay, you can't do that one. So the correct way to deal with this is the following. So let's say we have here x squared minus 1 over x minus 1. The correct way to deal with this is to apply a similar trick here a while ago. And that is to split this one as x minus 1 times x plus 1. So that's the factorization when you have a difference of two squares. Yeah. There. Then this will be the denominator that cancel this time the common factors. So again, you can cancel. The key idea here is that you can't cancel over sums or differences, but you can cancel over products. So this will leave you with x plus 1. So as you can see, although we got the same answer, so this one is equal, the process here is incorrect and the process here is correct. So this is an example of correct outcome but different process. So for the different process, for the incorrect process, you might get 0 points or just partial points, but for the correct one, you get full points. So yeah, so those are the two mistakes. We still have 3 more. Yeah, so maybe I can write this one here. So let me line this one up. It will be around here. Okay, maybe around here. There. So we have here mistake number 3. This third mistake, I coined it, or I named it as invisible parentheses. Another common one. So suppose we have like this expression out here. A common mistake of student is that they omit or they forget the parentheses. This will just yield x minus 1 minus x plus 2. And when you simplify, this will leave us with, so the x's would cancel out, we'll be left with 1. But take note that this one is absolutely incorrect. And the key error lies in this term, okay, the plus 2 out there. Let me show you what is the correct process for this one. So let's say we have again x minus 1 minus x plus 2. The correct process is to distribute the negative here into the two terms. That will give us x minus 1 minus x minus 2. As you can see, these two are quite identical. It just differ in this part. This will yield, when we simplify, this will yield negative 3. So that is a common error that I commonly see. Although it's just subtle, when you start this mistake in the beginning, it would compound eventually as you go on with your solution. So yeah. So let me just put where this is commonly seen. So let's see. Commonly seen. Maybe on the following. Yeah, so first, it is commonly seen when you apply the quotient rule in derivatives. So what is the quotient rule? See, we have, let's see, d over dx of, let's see, this is f of x, this is g of x. The quotient rule states that when we obtain the derivative of this quotient, we'll have the following. So g of x, f of x. Oops, there's a mistake here. It's g, f prime of x minus f of x times g prime of x. Or usually the mnemonic here is low derivative of high minus high derivative of low, over low squared. So where do this error usually arise here? The error arise in this one. Let's fix this one. It usually arises here, and that is because we have here minus this certain expression. When a student forgets that this thing should be distributed to whatever thing you obtain here, then that is where the error arises. Next one is in, let's see, what else? In the fundamental theorem of calculus. So fundamental theorem of calculus. In particular, it arises when we have like the integral of from a to b of f of x dx, and you'll obtain its form to be f of b minus f of a. The error arises out here. And that is because, again, we have minus a certain expression. So yeah, that arises most commonly there. And then last place where it arises is the area between two curves. So area between maybe curves. So if you would recall, the formula for this one, for at least the vertical rectangle scenario, is that we'll have like top of x minus bottom of x. So let's say this is a, this is b, dx. So it arises out here. Since, of course, if you made a mistake out here, that would yield a different outcome or a different area. So you won't get the exact area between the two curves. So yeah, so these are the most common application of this error. So make sure to be careful of that one. I had to highlight it because it's really evident. For the other mistakes, these are usually seen everywhere. So I can't highlight a specific portion where it is seen, since it is seen everywhere. Okay, so last mistake for this one. Let's write it here. So mistake number 4. This fourth mistake is, let's just name it as trigonometric notation. Yeah, but I'm guessing that this also applies to hyperbolic since they are quite similar, but let me just focus on the trigonometric one. So common error here is that if we have sine x squared, what student most of the time do is just put the square inside the x, leading to sine of x squared. So this one is incorrect. The correct way to do this is the following. So let's have here sine of x squared. You can view this one as sine of x times sine of x, which would yield us sine of squared x. So the one that is squared is sine, not x. So there, so careful of that one. And then finally, I always see this in every generation of set of students. When we have sine inverse of x, one will view it as 1 over sine x, which is just equal to cosecant of x. This is an absolute head scratcher. That is incorrect. Take note that sine inverse of x is defined as arc sine of x, or basically it's an inverse function. So let me write it here, a function. Yeah, so it's okay. Let me be specific there. So let me put it up here. A defined function. So it's not just the reciprocal of sine x. It is a defined function. More specifically, it is the inverse function of sine x. It's kind of like exponential and logarithmic. They're inverses of one another. So yeah, these are the most common calculus killers that I could think of. Let's see. Let's just, maybe we can adjust, remove the background pattern there. So these are the most common errors that I see on a work of a student. So I hope you don't make these same mistakes. That's why I laid it out for you. There, so yeah, I hope you enjoyed this one. If you have any video suggestions, you can just comment that one down below. And yeah, besides that, have a great day.